Now we're going to start talking about power management. Hit it.
The first thing that I'd like to talk about is the batteries. The batteries are the heart of any power system on a sailing vessel. And we have two 24-volt, 300 amp hour lithium iron phosphate batteries from Lithium Valley. And you can see here how they arrived on Aquarius 1 year ago.
Because of the size of these batteries, now what I can do is I can move this one down just a little bit, move these just a little bit closer together, and I've got enough room down here for one more battery.
And that, my friends, would be a lot of battery capacity. Now, I don't want to spend a lot of time on the specification, but I will say this. They beat out AGM and gel batteries on weight, energy density, charging rate, discharge rate, lower resistance. That means you'll be able to use more of the power you generate. They're better for the environment, and they're gonna last longer. And now, they even cost less. Take a look at the top left graph. That basically shows you longevity. And longevity has a lot to do with your depth of discharge, how deep you discharge your batteries. I plan to keep my depth of discharge less than 55%. This should give me 5,000 cycles before my batteries lose 20% of their capacity. So if I cycle my batteries 300 times a year, which is probably about average for a liveaboard, I may get 16 years before my batteries are at 480 amp hours of capacity, which is still more than I need. Take a look at this line. This line is an AGM curve. I had my AGMs for about 4 years, and they ended up being about 50%. That means on average, I was cycling my batteries less than 200 times per year. If I did the same with my lithium batteries, they would last over 20 years. Maybe between 2035 and 2040, I may just have to change the batteries on Aquarius. Now let's take a look at the discharge curve. Because I'd like my batteries to have a long life, and I want to get as much power out of them as possible, I want to keep my discharge rate below 0.1 C. Now, somebody might look at this graph and go 0.1 C at 10 hours, 0.2 C at 5 hours, 0.5 C at 2 hours. Basically, that's all the same. Looking at my system, if we do the math, they all come up 600 amp hours. But power equals watts equals voltage times current, and you lose the power in the voltage drop. The higher the current, the larger the voltage drop, and you could lose as much as 7% of your power. Now let's take a look at the discharge specification. We just want to make sure that these two Lithium Valley batteries will work for Aquarius. Now, surely they'll be able to handle the normal loads, which are 10 to 30 amps. But let's look at the largest load, and that would be the bow thruster, and it uses 480 amps. The max continuous discharge for one battery is 200 amps, but we have two, so we have 400 amps. And the peak discharge current is 400 amps, and that gives us 800 amps of peak current out of these two batteries, and that surely will handle the bow thruster. I'm really not sure about the cutoff voltage at the low end, 20 volts. I believe that's actually 24. As mentioned earlier, I want to keep my discharge rate or discharge current below 0.1 C, which for my system is 60 amps. Except for when I use the bow thruster, winches, or windlass, I expect to be well below this self-imposed limit of 60 amps. This exercise reminds me of a funny story. 3 years after adopting Aquarius, I named the bow thruster the ML battery killer because it draws 480 amps from my 440 amp hour AGM battery bank, thus the nickname. When I told a group of Amel owners of my nickname for the bow thruster, some were very upset. But one told me, "You didn't get the memo. You should always start your genset, turn on your battery charger, before using the bow thruster." That means every time you dock your boat or plan to use a bow thruster, you have to start the genset and the battery charger. And this would only drop the discharge rate to just under 1C. I rest a little easier knowing that with my lithium iron phosphate batteries, I won't have to. Let's look again at the depth of discharge chart. In order to stay below my depth of discharge limit of 50%, I will limit my depth of discharge to 300 amp hours. Yes, I could use more, and I will if I need it, but for day-to-day operations, I will try to stay within my self-imposed limit. On an average night, between 6 p.m. and 6 a.m., Aquarius uses about 2.5 kilowatt hours, or approximately 100 amp hours of capacity. Thus, staying within our limits, we have 200 amp hour that we can use if needed. An AC unit uses about 35 amps. If we use one of our 3 AC units for about 5 hours a night, we will still be within the 50% depth of discharge limit. And that, my friend, is a game changer. This is a list showing voltage to depth of discharge for an AGM battery. Using AGM batteries on a 24-volt system, you will cycle the voltage from about 26 volts down to about 24.14 volts. This would be considered one 50% cycle for an AGM battery. You charge an AGM battery to a higher voltage, but it quickly comes down to about 26 volts when you use it. Thus, you are always cycling an AGM battery at the top end of the voltage range. Lithium iron phosphate batteries are different. They like to be around 50% capacity, and they will last longer if you keep them close to 50%. They should be cycled around the 50% capacity point, and you should store them at approximately 50%. This slide shows what I'm aiming for when I cycle my lithium iron phosphate batteries. Over time, I will adjust the charge voltages on my solar chargers to match my usage. But I know this might take time after I start moving across the Indian Ocean. If, in the morning, the voltages are higher than 25 volts before the solar starts charging, I will turn down the voltage on the solar chargers, and will do the opposite if the voltage is lower than 25 volts. And if my battery voltage is very low in the morning, I will use a genset. If the voltage is always low, then I will need to adjust my power consumption or buy more solar. The two bottom graphs show charging characteristics, but to be honest, they don't really tell me much about the batteries the way I use them, because the data was taken at 0.5 C, and that's 300 amps for my batteries. On a very sunny, windy day at high noon, with 2,000 watts of solar on deck and a genset running with both battery chargers on, Aquarius would have a tough time charging at 200 amps, let alone 300 amps. Let's now take a look at what charges the batteries aboard Aquarius. So as you can see, at most I could charge at 200 amps, but the good thing about this is I have a lot of redundancy. When running your main engine with a house battery alternator charging lithium iron phosphate batteries, there are some things to think about. Most alternators, like the one on Aquarius, charge the batteries to a particular voltage. Mine is set at 28.4 volts, and the alternator will supply as much current as possible until that voltage is achieved. 1. This is okay, but not ideal for long periods. If you need to run your main engine on a passage for a long period of time, the battery voltage will remain at 28.4 volts after the batteries are full. It might be better to turn the alternator off once the batteries have reached the desired capacity. A simple switch might be a possible solution, but this might be the ultimate solution. Smart Regulator is selling an adjustable regulator. I'll put a link below for information about Smart Regulator. And if Smart Regulator would like to feature their ZM5 or maybe a ZM6 on Aquarius, I would be all ears. The lithium iron phosphate batteries have a very low internal resistance, and they can take on large currents until they are close to 100% capacity. You may need a temperature sensor on your alternator because charging a large bank of lithium iron phosphate batteries could overheat some alternators. Aquarius has a 200 amp alternator that is regulated to 90 amps due to low RPMs of the main engine, so this is not something I worry about. And lastly, 3. Lithium iron phosphate batteries, internal BMS, will switch off the batteries if charged over 29.2 volts. If for some reason your alternator voltage goes over 29.2 volts and the batteries switch off, or for that matter, if any battery type is disconnected from the alternator suddenly, this could fry your regulator or maybe even your alternator. Shown here is a part that can be installed to protect your alternator and regulator. But if your alternator did supply over 29.2 volts, you may want to change that regulator. Lithium iron phosphate batteries like to be at 50% capacity, so don't keep them at lead acid float voltage, which is 27.14 volts, for long periods of time. If you're in a marina and you need to keep the charger going, set the float voltage at a lower voltage, maybe between 25.8 volts and 26.1 volts. If you think you're going to need the batteries at night because of a power failure, set the voltage to 26.1. If not, set it lower. Adjust your float voltage for your usage to keep the batteries as close as possible to 50% capacity. A few things to think about when using lithium iron phosphate. 1. Keep the depth of discharge as low as possible. Yes, you can cycle them from 100% to 0%, but they won't last as long as if you cycle them from 80% capacity to 30% capacity. 2. Discharge them slowly. Yes, you can discharge these batteries faster than lead acid, but still, the slower the better. 3. Charge them slowly. Yes, you can charge these batteries faster, but it is better and they will last longer if you charge them slowly, like with solar. 4. Lithium iron phosphate likes to be at 50% capacity, and that's between 25.8 and 26.1 volts. So the longer and more you keep your batteries closer to 50% capacity, the longer your batteries will last. 5. Don't charge them if they are less than 0 degrees C. This will be the one thing that breaks your batteries. 6. Don't overcharge the batteries. If they go over 29.2 volts, the BMS will probably shut it off, and this might cause a problem on your boat. 7. When you connect your batteries for the first time, make sure that they're at 100% capacity. And that's because if one battery is at 100% capacity and the other battery is at 80% capacity, the 100% capacity will try to fill up instantaneously the 80% capacity battery. This could cause a problem and break your batteries. 8. Don't let your batteries get below 24 volts.